Probability of obtaining a sample statistic at least as extreme as the one you calculated. So,
which hypothesis do you assume is true?
I'm going to say null.
Is it null?
I think it's null. You assume that the null is true unless it's proven wrong.
Sweet.
Which the following represents the hypothesis for a two-tailed test would be mu does not equal 10.
Yeah.
Question 6, which of the following represents the alternative for a left tail? I think the arrow is pointing towards the tail, is what I look at it as. So the top one is mu is less than 10.
Yeah.
Which of the following represents the alternative hypothesis for a right-tailed test?
And that's the opposite.
Yeah, the opposite.
Okay, so it's going that way. So it's the top one, right?
The second one.
What? Can't keep things straight in my head.
You're good.
Okay. Remember that we determine the outcome of the hypothesis test by
Listen.
Using information to answer the next two questions. Okay. Which relationship would result in failing to reject the null hypothesis?
So the little phrase on the if the p is low, reject the null. So I assume if p is above the alpha symbol, then you would not reject it or fail to reject the null. So I think the top one.
Okay. Yeah.
And then the opposite is question 9.
Yeah. Insurance company.
Average claim 1,500.
Insurance. Our funder probably That's the third one, right?
Yeah, average claim is greater than 1,500.
Awesome.
Null hypothesis.
It's equal to?
Equal to, yeah.
Okay. Insurance company selects and insurance the defendant. Is that a good assumption?
I said because it's above 30.
Yeah, it's a good sample size.
Yeah, it's a good sample size, so.
Yeah. Or largest is your answer. Question. That's the law. No, central limit theorem.
Yeah, central limit theorem. Yeah.
Which the following test statistic defining the lesson. So
in the lesson, I saw it says Z is the test statistic and X bar is the sample mean.
Yeah.
Mu is population mean. So Z. And then information. The historical mean of sales receipts at a grocery store is 150, standard deviation 40. Manager suspects the average has decreased. She sets up a hypothesis. Mu equals 150 is the null hypothesis. Alternative is less than 150. Standard, let's see, level of significance, or the alpha is 0.05, and then takes a simple random sample of 36 sales receipts from her store and computes sample mean of 144.
Yeah.
What is the z-score associated with this test? So I'm going to open up an Excel document to do this. Deviation. X. And z.
It's square root of 40, right?
It's the, let's see, standard deviation. So it would be 40 divided by the square root of the sample size, which is 36. And what's x is 0.05 or 140. Let's see. This equals. So what are you saying for x? For finding the z? Yeah, because it's like.
I'm pretty sure we're using the sample standard deviation. Or the sample mean.
Sample mean. Okay. Yeah. No, that makes sense. So that's 144. So this equals 144 minus the mean divided by standard deviation, which is divided by the square root of 36. So I got negative 0.9.
That makes sense.
But then where does the alpha come in? She will use a level of significance of a equals 0.05. So z-score, how to find the z-score? Oh wait, no it doesn't. Okay, yeah. So on the lesson, so we don't do anything with the alpha until after negative 0.
And that's the p-value associated with the z-score. So that's where the level of significance comes in, right?
Probability, okay. When computing p-value, we need to continue this logic. So we would have considered the value of z to be equally as extreme as this one, okay? In the case of a two-sided test, for one mean with standard deviation known, the p-value is the area in the tails beyond the plus or minus z. So, okay, so we'll go to the normal probability applet, or the, probability applet.
And we're putting in the z-score.
Yeah. Negative 0.9. And then we're trying to look for the p-value of the left side. Because she's looking for less than 150.
Okay.
And that would be.
And that's the area,
right? Yes. Let's see.
So wait. Okay. So the p-value of this is 0.1841, right?
That's what it looks like, yeah.
Okay. Cool.
0.184.
Cool.
What inference would you make about the null hypothesis for this problem?
P is low.
So
right.
the P, because the alpha, right, was the check,
Mhm.
and that was 0.05.
Yeah.
And so this is still higher than it. So I'd say failed to reject the null.
Our p-value is higher?
Yeah,
Isn't it
because
0.5? Oh, 0.05. Yeah. So we failed to reject it.
yeah.
Sorry, I missed that.
No, you're
0.5.
totally good. You're totally good.
Needs to be a weekend.
It does. I feel you, man. Oh, why does my computer keep? It just zooms in and out all the time.
What is your conclusion for this problem? What do you mean? Yes. The true population mean.
We have sufficient evidence that the true population mean is 150. We have insufficient evidence that would be the third one. We have insufficient evidence that the true population mean is less than 150. Or
I think we have sufficient. Because with our z-score and stuff, I'm not even sure. Well, it says greater than. I think we'll go with we have insufficient evidence.
the third one?
Yeah, taking the lead on this one pretty good.
Yeah.
I'll trust you.
Well, I don't know. It was late when I did my homework, so. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the hypothesis is true?
Whenever we reject a true null hypothesis, we say that type 1 error was committed. So, type 1.
Type 1, sounds good.
Yeah.
A researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. True. Probability of a type 1 error will increase. Type 2 error will increase. Null hypothesis is true will decrease, or his experience will be scientifically valid, more scientifically valid. So let's see.
Type 2 is the HO is false, and we fail to reject. Okay. So we just have a false one, right? So probability of 2 would occur, or a higher probability of type 2.
The probability of type 2 would increase. I think so, yeah.
Okay. That's all I'm really getting, because there's this table here, and so the type 2, if we're changing these types of things.
Oh, yeah. Fail to reject HO, type 2 error. Okay, that makes sense.
Hopefully.
We'll see. If alpha equals 0.05, compute the probability of committing a type 1 error. Oh, wonderful.
Right.
So, let's see. Finding the probability.
And it's 0.5, right, that we're computing from?
0.05, yeah.
It says right middle. I think it's just because here it says 0.05 seems to strike a good balance between the probability of giving 1 and 2. Or, data. See, it's like 50-50.
What is it? Compute the probability of committing a type 1 error.
Okay. So this equates to 1 in 20. So if the null hypothesis is true, there's a 1 in 20 chance it will be rejected at 0.05 of the significance, our common choice for a. Okay. So it's a 1 in 20 chances, right?
Yeah.
Committing a type 1 error.
I mean, that sounds good to me.
Okay. And 1 in 20 is just 0.05, right?
Yeah.
Cool. I'll submit it real quick and then.
Okay, we'll see what happens.
Yeah. If it will submit, lovely times. You have to press these buttons.
I know, it just stresses me out every time.
Okay. 100%.
Nice job.
Sick, dude.
Whew. It's always stressful, you know. You
Yeah.
click that button and it's like everything is just weighing on it. All right, I'm gonna end this video and say that's all, folks.
Yay. Nailed it.